Hur känns det idag? Känns det bra? Ni nickar, vad härligt. Vilken dag det var igår. Både här inne, på sessionerna, ute i utställningen. Träffade väldigt många trevliga människor och var på en rad sjukt bra seminarier. Min favorit igår, det var hur kan IT bli hjältar i ledningens ögon? Helt fantastiskt. Många av de här sessionerna, de spelas in och de kommer vi lägga upp på TechDays hemsida så ni kan titta på det som ni missade. Hur var det med tävlingen? Har alla tävlat nu? Inte? Då måste ni ta chansen idag. Vi har jättefint pris i en Surface Pro, så ta chansen. Och många av de här utmaningarna är jätteroliga att göra, så passa på. Idag kommer vi göra en spaning in i framtiden. Vad är det som väntar runt hörnet? När vi internt på Microsoft hade vår kick-off i september så bad vi en av de framtida whiz-kids som finns i Stockholm idag att tolka framtiden med hjälp av en film. Låt oss välkomna Jonatan Salomonsson upp på scenen.
Hej.
Hej, välkommen.
Tackar.
Så vem är du?
Förmodligen någon som tar sina hobbys lite väl seriöst kanske.
Det skulle man ju lugnt kunna säga. Så när du då fick det här uppdraget från Microsoft, tolka framtiden, hur tänkte du då?
Såklart väldigt kul. Stort fan av idén utav framtiden. Så många här inne också, förmodligen, hoppas jag. Så ja, kul.
Vi ska ju strax få se den här filmen, men lite, vad är det du vill förmedla?
Jag ville visa på en värld bakom låsskärmen i och med att temat var Unlock Microsoft. Så pushade på det och ville visa en värld som var helt automatiserad såklart. Och då grundpelaren i hela samhället ur alla aspekter var just teknik och så.
Och vad jag förstår så är du en riktig multitalang. Du har gjort graffitin som vi ser här på sidorna som finns på NK i Stockholm. Du dansar och du har ju faktiskt skrivit musiken också i den här filmen, eller hur?
Ja, precis. Jag har gjort allt i videon själv. Modellerat alla byggnader och texturerat, gjort alla ljud och så själv. Och så, ja, musiken blev lite i sista sekund, men det blev bra ändå, tycker jag.
Du skrev ju den sista delen i bilen på väg in.
Ja, vid sista tweaksen blev bilen på väg till eventet, ja.
Så varifrån hämtar du din inspiration till den här multitalangdelen?
Plockar ju från många ställen. Musik, film, konst överlag. Men också så här vardagliga situationer som man inte riktigt tänker på. Kanske typ när man är på tåget på väg hem så ser man någon så här del utav tåget som man bara, det där är nice form typ. Så fortsätter man på det hemma och liksom bygger vidare så det kan komma verkligen från var som helst. Liksom. Så.
Underbart. Sista frågan. Vad önskar du dig mest av allt just nu?
Startkapital.
Någon? Det är dags att titta på filmen. Stort tack, Jonatan. Trevligt att ha dig på scenen. Inte för att ge någon ångest här, men han är 18 år. Time to switch language again. We're extremely proud to have Jennifer Marsman as one of our keynote speakers here today at TechDays. Jennifer is the principal software development engineer at Microsoft, and last year she was recognized as one of the top 100 most influential individuals in AI and machine learning. Please welcome Jennifer Marsman.
The headset that you see on the screen behind me is a headset that can read EEG, or your brain waves. And I took this headset, and I put it on my husband, and I asked him a series of questions. And first, I had him tell me the truth, and then I made him lie to me. And what that gave me is a labeled data set of what his brainwaves look like when he's telling the truth and what they look like when he's lying. And from there, I could feed that data into a machine learning algorithm and build a classifier to perform lie detection. So that's what we're going to talk about today. So when I think about how this idea got started, I started thinking about what we do for lie detection today. You guys probably watch the same criminal dramas here in Sweden that I do in the US, but you can see that there's a lot of ways to beat polygraphs. The typical polygraph is, contested and not always applicable in a court of law nowadays. And typical polygraphs measure things like galvanic skin response, how sweaty you get, heart rate, rate of breathing, those types of things. And it is possible to get around those and to fake some of these things. You see how government officials and such have training to actually be able to, moderate their heart rates and things like that. And so I don't claim to be a neuroscientist. I am definitely not. I do have a machine learning degree, and in graduate school I studied machine learning, and I did take one class in brain science, and one of the things I learned is that when you are telling the truth, that activates the recall centers in your brain. And when you're lying, that activates the creative centers in your brain. And so I started thinking, if I had this headset that's reading from these, 14 different points on my head, would it be possible to differentiate between those? Seemed like it might be possible, and that would be harder to fake, and that this might be a better way. So I set off as a side project to see what I could do. So I did use my husband as my initial test subject, and I sat him down in a chair. I made him close his eyes, and there was actually two reasons for that. One reason was that I was actually reading the questions to him. So I was asking a question, and then I was actually annotating in the data when I started talking, and then he would answer the question, and I would put another marker in the data, so that way I could extract out just the part of his brainwave signals where he was actually thinking about the answer to the question. And so I made him close his eyes so that he wouldn't read over my shoulder and be able to anticipate the question and start thinking about it sooner than and mess up my data for when I was pulling it out. That was one reason. The second reason was that EEG data actually is very noisy data, so facial movement gets picked up in EEG as well. If you look at the developer SDK that comes with that headset, they actually have event triggers for things like blinking to the right and blinking to the left and those types of things, because those are all picked up in facial movement. So I wanted my data as clean as possible to test, and so I had him close his eyes and not touch his face and try to get nice clean data to try this out. And I ran a tool called Test Bench, and I can show you a little bit of the data that actually generates. I put a whole bunch of things, asked a whole bunch of questions here, and then it created it stores it in a proprietary format, which is then dumped into a CSV. So if you look at it here, here's some of the data that we have access to. There's a counter. I didn't use that. So the headset actually takes readings at a rate of 128 readings per second. And if you do the math on that, that actually works out to approximately every 8 milliseconds it's taking a reading. And so this counter just counts up to 128 and then resets. So I threw that out, and I threw that out as well. But here is the interesting data. These channels are the 14 channels that are actually touching the scalp. And so you can see they have funny names like AF3, F7, F3, O1, and O2. I'll show you where those map to in positions in the skull in just a second. So there's 14 of these different channels, and it was taking readings on all of them. There's actually also some gyroscope data, which is interesting, so you can get positions of the head. Do you guys follow the World Series of Poker here? No, not so much, maybe, sort of. So I know that the experts on the World Series of Poker wouldn't make these mistakes, but sometimes if you try to catch someone in a lie, they may have a little tell, like they tilt their head a certain way or something like that when they're not telling the truth. So there might actually be some signal in this data, but so I have kind of like a to-do to play with that more later. But in my initial work, I didn't use the data from the gyroscope. This is the marker column. So when I was annotating the data and putting in markers when I stopped speaking and when my husband stopped speaking to be able to extract out just the brain activity during the time when he was thinking about the answer to the question, that's how I did it, was using these markers. And then they also, the tool also captures the timestamps. So this is good time series data. It does capture it in seconds and milliseconds as separate columns. And so I actually did some math on those, you know, the seconds times 1,000 plus the milliseconds to be able to make the math easier. And then we also have these 14 different, this is again a repeat of the channels, but you see this CQ underscore before it. And that stands for contact quality. So that's a reading for how well it's picking up signal strength. So you can see right here when you first put it on, they're all reading zeros, but then 4 is actually full signal strength. And then once it's been on for a second, you can see all of them go to 4 there. So this is the contact quality of each one of those individual nodes on the head. And so this is a really good thing to use for data cleaning to make sure you're getting nice clean data where you're getting full signal strength. And then all the data up to here is data that was produced by the tool. But starting here, I added 3 columns myself. The first is my label column. So in machine learning, you have a bunch of features which help predict something. And then you have a label, and that is kind of the thing that you're trying to predict. So in this case, I was trying to predict if something was the truth or not. So I did label, this was user 21, their truth data. So I labeled this as 1 for yes, it is the truth. This is the time column that I did, the milliseconds plus seconds times 1,000. And then after I did the initial work with my husband, I started collecting data from more people. So this is user 21 for privacy reasons. All right, so that's a little bit about what the data looks like. So I collected the data like that, and then I asked, you know, all of these other questions, yes, no. I asked him the questions that you see there, and some of these, the correct answer is yes, and some the correct answer is no. And that was because I wanted to have a nice, you know, confusion matrix of true, false, and then yes and no, and get, you know, data in all 4 quadrants there. So, for example, are you married? Yes. Do we have a dog? No. Does he have a PhD? Yes. Does he have red hair? No. Do you have 5 children? No. Although we don't have 5 children. He might have 5 children, but if so, we have another problem. But he answered all of these questions, and I asked him the truth, and then I repeated it for lies, and so I got a nice labeled data set of truth data and lie data. And here is some documentation, some photographs of the actual testing process. And you can see that my husband is thrilled to be helping me with this research. I swear I don't have an Ashley Madison account. We're very happy. So here's a quick look at the sensor quality as well. You can see this is a screenshot of one of the tools that's used with the headset, and those are the various points on the skull. Now this is a top-down view, so you're looking at the top of the head with the ears on either side, and that's the nose you see along the top. And so you can see where the readings are and what those look like. And those are some old screenshots that I took at the very beginning when the sensor quality wasn't all the way there. But you can see that 4, this was the data that we saw in that CQ underscore in the CSV earlier. But signal strength of 4 is the strongest signal strength where things are going well, and that's represented by green in the diagram. And then 0 means you're not getting any signal at all from that particular node. And then there's levels of progressive degradation in signal quality. So that's a really good thing to use with data cleaning and being able to make sure I'm getting good signal quality if I'm using the data. And then here is the mapping of where all of those columns map to on the various places on the head. So you can see AF4 and AF3 and AF4 right here. The 07 or 01 and 02 are right here, and the T's are right above the ears. And so those positions all map to the various places on the skull. So I could use that for information on where the various sensors were coming from. Now, when I was doing this work, I did do what is very common. I stopped for a second and thought, someone has got to have thought of this already, right? Every time you have a great idea, usually someone has thought about it. So I did go out and do some research. Has anyone done anything with lie detection and EEG before? And I did find one piece of research which was a little different from what I was doing, but it was using this concept of the P300 ERP. So ERP stands for Event-Related Potential, and that's another way of processing EEG that uses some averaging and such. And the P300 ERP essentially measures recognition. So if you were walking through the expo hall yesterday and you saw a face and you got that flash of, oh, I know that person from somewhere. And maybe, maybe it was from, you've seen them at a user group before, or maybe they were in your, class in school or something like that. But you get those, your brain is doing that pattern matching where it recognizes that face and kind of lets you know. And so that reaction is an instinctive reaction, and that's the P300 ERP. And what it looks like on a waveform is exactly what you see in that chart on the left. So you can see that little dip, that P3 dip that you see there. And the reason they call it the P300 is because it occurs roughly 300 milliseconds after the visual stimuli. So right after you, about 300 seconds after you see the thing that you recognize. And then the chart on the right is just a very complicated way of showing some additional data. So here's how it was actually used by law enforcement officials. Instead of actually, putting someone through a polygraph where they were asking them yes or no questions and monitoring responses, they instead put an EEG reader on their head and then asked a bunch of questions, or instead of asking questions, they showed images, so showed visual images. So you can show some neutral images, like, a piece of fruit or whatever, and then show, the crime scene, or a picture of the murder weapon, or those types of things. And if the suspect in question has that flash of recognition, then we do know that they have some intimate knowledge of the crime that was committed. And so then the chart on the right-hand side is actually just a very overcomplicated way of saying that if there's a correlation, if the data that the person recognized correlates with something that only a perpetrator of the crime would know, then they might be guilty, right? Kind of obvious there. All right. So I collected all this data. We got to the data collection part. I did some cleaning and things like that. And then I used Azure Machine Learning Studio to process this data. It had just come out, and I wanted to try it out and was playing with this. And Azure Machine Learning Studio is a great tool. It gives you access to 25 different algorithms. And then there's a lot of easy modules for doing data cleaning. So you can just drag and drop and wire up a data flow really quickly, and then easily swap in and out algorithms and things like that to almost do rapid application development of machine learning. And so I use those things, and then you can very easily train and test models. And then it's literally a button click to just deploy, and it stands up a REST endpoint, and then it generates a GUID, and only people with the GUID can call the REST endpoint. And the deployment story is just so nice and easy. So I chose to use that. And here's a quick example of how you might do supervised machine learning. One pattern is you import a data set, you do various data cleaning, and I'm not going to go into depth on data cleaning in today's talk, but if you do want more information on data cleaning, there's another talk that I do using data from the Titanic and being able to predict whether or not someone survived or tragically perished on the Titanic based on demographic information, age, gender, how much they paid for their ticket, things like that. And so you can, if you want, I'll give you a link in just a second for where you can see that video. But I go into a lot of depth on data cleaning in that video. So then in machine learning and supervised machine learning, we split our data. And the reason we do that is because if I train an algorithm and I give it, for all of these brainwave data, for what this time series brainwave data looks like, here's whether they're telling the truth or lying. And then I want to test it, and I say, okay, for this series of brainwaves, what's the answer? That doesn't really tell me much, right? Because I trained with that data. And so it's going to know or have an approximately good idea of what the answer already is. So the real measure of how well your machine learning algorithm performs is how well can it do on data it's never seen before. So what we do typically in machine learning is you split the data, and there's lots of different ways to do this. If you have a sufficiently large number and the law of large numbers is working for you, you can just grab a random 30% of the data and hold that back, and then train with maybe 70% of your labeled data set. And so, but there's other ways to do this as well. There's k-means cross-validation and a couple of other techniques if you don't have sufficient data to do that well. So I split my data in some fashion, and then I use some amount of that data as my training data, and I feed that into a model. And then I also feed in some algorithm, and the algorithm just determines the type of crazy beautiful math that finds the correlation between that label, the thing that I'm predicting, and the features, which are the things that affect my label, right? So with that, I feed in some algorithm, and then I give it the training data. It builds a model internally for what that would look like or what those correlations are. So it's a mathematical model. And then we output that model into a scoring module. And what that can do is it will then feed in that test data, and so say, okay, for these new brainwave patterns model, tell me what the answers are. Is this telling the truth or am I lying? And so it gives that back, and then you can compare that side by side with the right answers that you know since you held that data back, and then score the model and see how well it performs. And then finally, we can do that same thing with the evaluate module. What we can do is do the exact same thing in another thing, and maybe I try a different algorithm on the other side. Or once I've landed on an algorithm, I start messing with the initial parameters, which can affect accuracy a lot. So so that's kind of the art of data science, where you are kind of tweaking things until you find a model that fits your data very well. So you can do that all at once. And so then the next thing would be, okay, Jennifer, maybe that kind of makes sense, but if I don't have, you have to feed in some algorithm, and you said that there were these 25 different algorithms in Azure Machine Learning, so how do I know which one to use? So enter the Azure Machine Learning cheat sheet, cheat sheet, cheat sheet, cheat sheet. So this is a wonderful resource that tells you exactly the kind of algorithm that you can potentially use. So you start with the nice friendly start button in the middle, and then you can map to the kind of task that you're trying to perform. So the task of trying to figure out, is someone telling the truth or lying, that is a classification problem because you're distinguishing between two, distinct buckets, truth or lie. And so we would go to this predicting categories on the right-hand side. And then am I trying to distinguish between 3 or more or 2 categories? I'm trying to distinguish between 2 because I was asking very clear-cut binary yes or no type questions. I did not ask questions like, does this dress make me look fat? Where the answer may be somewhere in between. Very, very binary type questions. All right. So once we have that, if you would like to download it, the cheat sheet is an amazing resource to print out and hang in your office like all the cool kids. So you can download that at that link. And then there's a whole bunch of resources on getting started with Azure Machine Learning at the HackML link. And then the video that I mentioned before where I go into more depth on data cleaning is right there. So those are more resources if you'd like to learn a little bit more. All right, so let me show you. I built this prototype, and then let's see what we've got here. So here is my initial prototype that I built. And so this was just using the data from my husband. And if I right-click and visualize this early data, you can see what we've got here. So let me show you how to read this chart if you're not familiar with this chart. So what this is plotting is the false positive rate versus the true positive rate. And false positives are bad. False positives is when you say something is true and it is not in fact true. And then, or you're predicting that it's true and it's not in fact true. And then true positives are good. That's when you're predicting something is true and it is in fact true. So perfection would be if the false positives were 0, so kind of going along the 0 axis here, and if the true positive rate was 100%, which would be like right here. So basically, if this is perfection, so actually the tighter your line hugs this curve, the better that your algorithm is doing. And then this right here, it's kind of hard to see on projector sometimes, but there's kind of a gray line across the middle, and that's essentially 50-50 random chance, a monkey flipping a coin. So if your algorithm is not doing better than that, start over. Something went wrong. So this one was kind of doing okay, but this one was doing really well. So this was using a decision jungle algorithm, which is an ensemble of decision trees. And using this algorithm, if I look down at the numbers right here, you can see my true positives and my true negatives are high, which is good. And my false negatives and my false positives were low, which was good. And then I was getting an overall accuracy of about 93%, as well as decent recall and precision numbers. So I started to think, oh my goodness, there may be something to this. And so it was really funny because literally 2 weeks after I did this initial work, my team had an offsite. And I work on a distributed team, so we're all over the US and the world now, actually. And we all get together, the whole dysfunctional family gets together like once or twice a year and have a big team meeting. And last year, or the year when this happened, we had a commitment where we had to deliver a certain number of Channel 9 videos. Do you guys know Channel 9? It's like Microsoft's YouTube. We publish videos there. It's channel9.mstn.com. So we had a commitment where we had to deliver a certain number of Channel 9 videos. And so our marketing team had actually brought a camera crew to our offsite in case we wanted to record any video when we were out there. They were really pushing the videos. So I got an idea. I was like, and I ended up grabbing a cameraman, and I grabbed my manager, and I said, hey, would you be willing to help me with, I'm working on this new project with that headset you let me buy, remember that? I didn't tell him all the details of the project. I just said I was going to do something cool with machine learning. So I was like, could I just get you on film and ask you a few questions? And he was like, sure. So first I needed a nice, clean, data set to have my labeled data set. So first I asked him a bunch of questions and had him tell me the truth.
Are you a female?
No.
Are you a male?
Yes.
Have you ever worked for Microsoft?
Yes.
Okay, so you guys get the idea, right? All right, and then I made him lie to me.
Do you have a PhD?
Yes.
He does not.
Do you currently have a pet?
Yes.
Do you have blue eyes?
Yes.
All lies, all lies. Now, what would you guys do if you had access to your manager's brainwaves?
Do you believe Microsoft is the best company in the world to work for?
Yes.
Am I going to get a promotion this year?
Yes.
Okay, so you guys all heard that really awkward little giggle, right? Okay, so I had to know, what did it mean? Did it mean I was really going to get the promotion, or that I really stunk and he just didn't want to tell me? So I did what any girl would do, which was run back to my hotel room that night and build a classifier with his brainwaves. So I put together this, so I took the training set that you guys saw and uploaded that all to Azure Machine Learning. I used the truth data and the lie data that was the clean data that you saw earlier. I built a classifier, deployed it, exposed it on a REST endpoint, and then I wrote this really ugly Windows 10 app to call it, because if any of you guys have ever seen a Jennifer Marsman UI before, they are not good. They make your eyes bleed. I'm sorry, not a design person. So just to and so this is actually calling the REST endpoint and displaying the data along with the confidence levels. So, do you believe Microsoft is the best company to work for was the first question. My manager said yes. My algorithm says, oh! He has an iPhone. I'm just saying. He's really into design. Who knows? All right. And then the real question, am I going to get a promotion this year? And he said yes. My algorithm says, yeah! Yes, I am delighted to announce that I did get the promotion. So, very, very exciting stuff here. I have done a number of things in addition to this as well. So I'm continuing this work and have a whole bunch of, I've refined the process a couple of times. I've been working with some other folks. I'm not going to go through all of this in great depth, but there's here's kind of the main points here. I am recording a neutral brain state recording as well, multiple markings in the data. One thing I do want to call out is the switching order to reduce fatigue effect. So this is kind of interesting. So if I was taking your data right now and you sit down in a chair and I put this headset on you and there's this crazy woman asking you questions, like it's kind of fun at first, right? Because this crazy person is asking you questions and you have this headset on your head and you feel like a cyborg and you're like, oh, this is fun. But then it gets boring really, really fast. All right, when you're sitting there answering questions. And so if I always ask people to tell me the truth first and then lie, then all of that kind of engagement would get captured in the truth data and the kind of boredom would get captured in the lie data. So to tease out kind of those confounding variables and make sure that I wasn't, just testing engagement level and how excited they were. For some people, I asked them the truth first, and then I had them lie. And for other people, I had them lie first, and then tell me the truth. So that way, that data would average out among all my data. And then there's a number of other things I did to improve this as well. And then finally, let me talk a little bit about the machine learning exciting stuff behind this. So there was a lot of different ways to pull features out of this EEG data. One technique is called unrolling the waveform, and that's something you can do with time series data when you have, I had data, remember, coming in from 14 different channels, and it was coming in over time. So essentially, if you think of, like, here are the 14 different channels, and then here is, every 8 milliseconds new readings, you can actually unroll that where I take all of this data and then add this data on the end and this data on the end and kind of unroll that whole time series data into a single thing, and that's one technique that works sometimes. So trying things like that. I've tried experimenting with wavelets, which is the idea of dividing a time signal into frequency bands. And for those of you who are familiar with Kaggle, which is a really cool data science website where you can do challenges and such, they actually had an EEG challenge a while back, and the winners were actually using really low frequency time signals. So that's something that showed that, okay, this might actually be relevant. So I was playing with that as well. I found an open source for Shangbao. I've never met you, but thank you. I leveraged a thing that he wrote as well, a Python EEG library that he wrote, and used some of the things that he put in there to try experimenting with that. There's also the idea of a state machine. So this is kind of interesting. So when you're thinking about answering a question, there's a whole kind of mini state machine that happens, right? You actually have to process the question, figure out what I'm asking. You have to decide whether you're going to tell the truth or lie. You have to think of a response, and then you actually have to do the work to vocalize the response. So there's like a little mini state machine that happens there. And so Markov models actually work fairly well with those kind of problems. So that's another thing that I was kind of playing with. Another thing is to have this work well across all people, there needs to be more data normalization. It works very well with, my husband and my manager, since I have data from them and nice training data right from their heads. But if I wanted to create a general purpose one that would work for anyone, I'm doing some work to normalize the data so that it could work well across any person. So one of the things to do that would be to compare to a neutral brain state to be able to do that data normalization properly. Because people have unique brain signatures where they actually kind of spike at different levels and things like that. All right, and then using ERP instead of raw EEG, there are some nice things about ERP. It kind of eliminates some of the noise more so than raw EEG does. Ensembling is another huge technique in the machine learning space right now, where essentially you combine multiple classifiers together to get an even better response, and subsequent classifiers can help improve the error of the previous ones. And then finally, deep learning. So I think this problem actually screams for deep learning. And the reason is it's very similar to the problem of speech detection, right, or speech recognition. And with speech recognition, we all have our own unique voices, timbres, accents, that sort of thing, pitch of our voice. But we're all saying, the same words. And so me saying a word versus someone else saying a word, we're going to have slightly different inflections, but it's the same word. And so the problem of speech recognition has essentially been solved with deep learning. And if you remember that waveform data, what it actually looks like is a wave. And so very similar to an audio file where you're seeing voice and how you can normalize that. It's same thing with brains. Everyone has their own unique brain signature, but if you could normalize that the same way. So I think deep learning really is the key to solving this. The only reason I haven't done it already is because for deep learning to work effectively, you need to have a lot of data, and I don't have sufficient quantity of data yet to do that. So getting there. All right, so in summary, this is an amazing headset. I have been having so much fun playing with it. Azure Machine Learning, phenomenal tool, helped me be effective very quickly. And husbands and managers beware, mind control is next. Thank you so much.
Thank you so much, Jennifer. Great passion. And don't miss Jennifer's session this afternoon. Det står vänner längst bak igen som har kommit lite senare. Ska vi försöka göra om samma sak vi gjorde igår och flytta ihop. Jag vet att det finns en rad platser där borta. Så kom in så att ni sitter bekvämt inför nästa session. And now, one of the most passionate people on this planet, with a rock star title, Microsoft futurist and distinguished engineer. James Whittaker, he promised to tell us about the truth, and he promised us to be right. Maybe we should connect him to one of Jennifer's headsets. I don't know. What do you say? Welcome on stage, James Whittaker!
Don't miss TechDays in Stockholm. I'm going to be speaking there. I'm going to predict the future, and it's going to blow your mind.
30 years ago, we lived in a pretty much 99.9% analog life. We didn't have smartphones. Very few of us had PCs. And even if we had a PC, it's 1987. They didn't fucking do anything, right? DIR, wow. And a completely analog life just 30 years ago. So if we look 30 years into the future, what are we going to be then? That's what we're going to do today. We're going to look into the future. But we're going to start back in that 30-year-ago period to understand how we got where we are today. In 1987, if you worked on a computer, you worked on a big-ass mainframe in some big-ass building for some big-ass company because they were the only people who could afford these things and could house these things. And if you worked for one of those big-ass companies, you did boring things. You did payroll, you did accounts receivable. And if I would have told you in 1987 that everything you know about computing is about to change, if I told you in 1987 that you are going to acquire customers differently, you're going to program differently, PCs are going to come along and take over. You might have laughed at me. You might have liked that big-ass computer, right? You might not have wanted PCs everywhere. But PCs came, they took over, and if you were one of those, let's keep these big-ass mainframes going, you spent the next decade chasing the people who made the bet on the future. And what really caused it, though, every single one of these disruptive periods is because of people like us, people who can code. Because the people who can code looked at the PCs and said, you know what? We can do different things. We could keep doubling down on this mainframe stuff, or we could invent completely new things to do, right? And as software developers, who wants to work on the old shit? Right? We all want clean sheet development. Right? You can do problems like resumes, your personal finances, kids' homework. By the way, that's what did it. That's what did it. That's what put a PC on every home and in every desk and in every office all over the planet. Homework. It turns out you can sell anything you want to people who have recently procreated. They'll buy anything, right? Remember baby Einstein? We convinced the world that if your fetus doesn't listen to Mozart, it's going to grow up and be dumber than shit. And so everybody went out and bought Mozart CDs. That's what did it. See, that's what causes these new eras to really take off, is software developers who innovate. And when software developers innovate, what happens? Users look at the innovations and say, hey, I want that. The innovation draws users. And those additional users draw more developers. Those developers innovate, which draws more users, which draws more developers, which draws more users, and all of a sudden, Sun Microsystems and Digital Equipment Corporation and Sperry and Wang and all of these companies are tanking. And then it happened to PCs. Right? If I told you 10 years later in 1997 that everything you know about computing is about to change, if I told you in 1997 that the way you acquire customers, the way you do work, the way work gets done is going to be completely different, if you didn't believe me, you'd have doubled down on your desktop software and it wouldn't have mattered. If you believed me, you would have gone to the web and you would have realized there's new problems to solve there. Right? Think about it. You can't build Facebook on a PC network. It's not Amazon.pc, it's Amazon.com. You can't build eBay without the web. All of these new things, they are new. They cannot be done in the old era. And so developers have a choice now. Double down on the stuff you've been doing for 10 years, or do the new stuff. Create new markets. Be the first one to do something cool. And so the developers began to write web code. Those innovations drew users. Those users drew the interest of more developers who innovated and drew new users, and you get this flywheel effect. That's what creates the new eras. Now, I was a Google employee during this era, and we didn't see it coming either. Right? If somebody would have told us in 2007 that, you know what, the most important computing device in the world is the one that people carry around with them all the time, we said, you're crazy. We kept doubling down on all the web stuff. We were wrong. We told the world, no, keep printing your driving directions. Do you remember that? And taking them into your car. That's what you want to do. You see, mobile did the same thing as the web, which did the same thing as PCs. It created entirely new markets. You can't build Snapchat for the web. It doesn't make any sense. You can't build Pokemon Go for the web, right? Go. It's a hint. You got to go out in the world, and you can't carry your PC with you everywhere you go. New markets. And so what did developers do? They looked at that and you can use location signals, you can do all this cool stuff. And they innovated. Innovations drew the users. More users drew more developers who kept innovating and drew more users. And all of a sudden that flywheel effect is happening in mobile. Now, here we are. This is the present. What's next? See, you got to ask yourself that question. And you got to answer it, and you got to be right. or you're going to be stuck in the mobile era when the rest of the world is inventing something new. So there's a couple of interesting things about this progression. First of all, look at the problems that are being solved. They're more interesting, they're more complicated, and they're more useful to more people. So that means whatever this next era is, it's got to solve new problems. And it's got to solve them in ways that developers look at it and say, I want to do that. And then the other part of it is how you get work done, right? In the mainframe era, we had to go to the office to use a computer. In the PC era, we had to go to Best Buy, buy software, and shove them into the disks and babysit our installs. In the web era, we had to go to our living room and fire up a browser. In the mobile era, we had to pull a machine out of our pocket. It keeps getting easier. Well, what's easier than pulling a machine out of your pocket and say, hey, I got a problem, I want to solve it? Well, what's easier is for the machine infrastructure to do it for us. What's next is autonomy. What's next are the machines figuring it out, the machines understanding, hey, my user is right there, my user needs some things, I'm going to make it happen automatically, meeting users where they are. That's the mantra for the era of autonomy. So let's take a look at what this might look like. Let's rethink intent, because right now in the mobile era, the way I express intent is I pull out my phone and I say, I want this. I need this. In the world of machines, they're going to already know that. They're going to figure it out. So I tweeted this a couple of years ago. This is old, but it's a good example. I tweeted this: traveling to Boston, New York City next week. Any locals who can hook me up with some good live music recommendations? And nobody said anything, right? I got a lot of followers, and many of them live in Boston and New York. I had 2 favorites. Why would you favorite this tweet? Seriously, if this is your favorite tweet, get the fuck off of Twitter. It's got nothing to offer you, nothing at all. So it's going to work differently because there's intent brimming here. Don't you think the airlines would be interested? Hey, here's a guy who's got some money. He's got a good job. He's flying from Seattle to Boston and to New York. Our airline flies those routes. And what do they do in the mobile era? The airlines, they sit and wait. Oh, he wants to fly. Maybe he'll go to our website and book a flight. Oh, wouldn't that be great? Oh, even better. Maybe he'll install our app. Wouldn't that be great? They're waiting for me to come to them because that's the way the web and that's the way mobile works. The machines don't need to wait. So I wrote a bot for this, Twitter bot. And my Twitter bot reads my tweets and tries to figure out how to help me. What does James need? This one's pretty easy. James needs live music venues in Boston or New York. There's a Bing API for this. Give it text and it pulls the intent out, forms a search term, and searches it. And so this bot specializes in Twitter. That's all it does is read my tweets, figure out my intent, and then sends that tweets to accounts that might actually help me. See, Facebook, Twitter, all these social networks are brimming with buyers and sellers. They're both there together. Ads are almost the worst way to connect them. And so then the tweet, it sends it, packages it up, and sends it. It turns out it found 2,500 accounts in Twitter that claimed to be live music venues in Boston and New York. And so it just sent it to them. And then all of a sudden, I begin to get back responses. And look at it. 1 minute, I got back 13 responses. Now, here's where I wished my Twitter bot knew more about me. It's new. We've only known each other for a little while. So it doesn't really know my taste in music because it could have done a lot better job. Right? Like the first one is the Boston Beehive. It's jazz. And I don't like jazz. I really don't like jazz. And I don't know why. Right? Every time I listen to jazz, I'm like, God, this is awful. No wonder the suicide rate is so high. And so you could imagine how the interface might play out. I could left swipe it. And my Twitter bot would be like, oh, okay, James doesn't like jazz. Don't show him that anymore. And you can imagine how these algorithms are going to learn your behavior simply by watching you interact with the machines. The second one is classical music. Now, I got to admit, we legalized marijuana in the state of Washington, and classical music is sounding a lot better. But I'm not quite high enough, so my left swipe might be a little more gentle, and my bot might recognize that. And then the last one, see, this is where the power of personalization really would have come in handy. Cage the Elephant is one of my favorite bands, and if my bot had been with me long enough, it would have known that, right? It might be that, some machine I wear or some machine that's sewn into my clothes has geolocated me at Cage the Elephant concerts all over the United States. It's my favorite band. I had no idea they were in Boston the time that I was in Boston. And so now you can imagine it might work a little bit differently. What if the Orpheum Theater had their own Twitter bot that combed Twitter for intent? Who wants to see some music? Who likes the bands that are coming to our place? And they could go out and get customers. This is not an ads economy. This is an intent economy. This is a value economy. And what happens here is you can actually complete that task. My bot talks to the venue's bot, buys my tickets. And so here's the key prediction for the future that I want you all to contemplate tonight when you go to sleep. Bi-directional discoverability. Me and my bot and our intent is going out and trying to, because the way it works right now is the web is static. You're like, I've been trying to find good beer places the whole time I've been here in Stockholm. And, and that's why I'm tweeting, by the way, so my Twitter bot picks those up. I got some recommendations from you all, but my Twitter bot actually found the better places, right? Tweet. At the same time, so the way it works now is I express my intent, and the web is static. I'm relying on Bing, I'm relying on Google to help find things for me. And the web is just stuck there. The venue owners they're just sitting there. They don't even know I'm searching for them. What if it was bidirectional? What if I had a restaurant and my restaurant was empty? And you know this because there are sensors. These are beacons, but you could imagine this is called in-market. You could imagine this beacon would be Wi-Fi connected. Right now, you have to be in close proximity to the restaurant, and the restaurant is literally asking you to come eat. So if you've expressed your intent, you've expressed your hunger in some way, or maybe there's some brain waves we can pick up that know you're hungry, and the restaurant knows it's half full, all of a sudden, both the searcher and the searched are active in this relationship. This is powerful. This is not the web as it exists today. This is something a lot more powerful. So now let's talk about data, because the way this works is by taking a problem and completely reducing it to data. And the best example of reducing a problem to data is self-driving cars. Think about it. Self-driving cars. Swedish people. I just said self-driving cars. And you're like, yeah, so what? Right? Volvo can do it. Ford can do it. Fucking General Motors can even do this shit, right? Self-driving cars. We take it for granted now. Why? Because the entire process of driving a car has been reduced to data. That's when the machines get really, really good. Think about it. The roads, the edges of the roads, data. Traffic on the roads, data. Obstacles in the roads, data. It's all data. Of course the machines are going to be good at it. They're going to get so good at it that it's not only going to be wrong for us to drive, illegal for us to drive, it will probably be illegal to manufacture a human drivable car, because the machines are going to get really, really good at this over the next few years, because it's all data. So here's what I want you to do. I want you to take the problems that you're working on now, and I want you to reduce them to data. And when you reduce them to data, then you can ask the question, what machines do I need to collect this data? What machines do I need to negotiate with people who have the intent to consume this data, and how will this all work? Beacons, sensors, and things like that. So let's take an example. Let's take the example of, I don't know, zombies. because zombies are real. Seriously, if you ever attend a talk about the future that doesn't have zombies, just walk out. They're wrong, man. This shit is coming. It's not movies like World War Z, they're not so much entertainment as really homework, right? You got to learn to survive. It's just a matter of time until this happens. Now, this particular zombie movie caught me by surprise because my date wanted to go see it. She had never wanted to see a zombie movie before. I'm like, what the hell's going on here? I didn't know it had Brad Pitt in it until I got there. She knew, and she also knew that he had a shirtless scene in this movie. You should have seen her. She couldn't wait. She couldn't take her eyes off the screen. Crazy. But then something weird happened. About halfway through this movie, my date pulls out her phone and she begins to share screen time, right? She's like, oh, something on my phone, oh, Brad Pitt. Something on my phone, oh, Brad Pitt. As weird as it sounds, whatever was on her phone won. She looked at it and she said, I'll be right back. And she walked out of the movie theater staring at her phone. I'm thinking, what is wrong with this girl? She's crazy. And I'm just thinking, Brad, please don't take your clothes off. Whatever you do, don't take your clothes off, because if she misses it, I'm going to have to describe that shit to her. Right? I've got enough body image problems without having to tell the story of Brad Pitt's perfect torso. Fuck you, Brad Pitt. Oh, I was sweating, but it was okay, right? She came back. She sat down about 3 or 4 minutes later. She just plopped down in her chair. All of a sudden, everything's fine. And I thought, that was perfect timing. You didn't miss anything. And then she looked at me and said, yeah, I know. And she showed me her screen. She's got an app that tells her when to pee at the movies. Somebody wrote an app for that. Judging from your reactions, you've not heard of this app. And yet, we have several thousand urinating moviegoers right here in this room. And yet, none of you all are customers. Imagine how the developers feel here. They've written an app that at one point, every single one of us could use, right? You ever go into a movie and there's a hobbit in it? If there's a hobbit in the movie you're watching, you're going to have to pee. It's going to be a long-ass movie. You're going to have to go. The hobbit's your first warning. So let's reduce this problem to data. And when you reduce it to data, there's really 2 pieces to it. There's the discovery of the intent, the discovery of the need to pee, and then there's the environmental awareness that the machines need to know what to do about it. So let's go through this. Here I am, watching this movie. Oh my God, zombies and Brad Pitt. What could be more perfect than this? And then halfway through, I realize, oh, damn, right? Oh. But then the data starts working on my behalf. Maybe let's make up a random name that we could call this AI. We'll call it Cortana. Just a random name, right? Cortana whispers to me, and I don't know how she talks to me. You can code this. Maybe it's the bone phone. Maybe she's built into the seat in the movie theater, and she's gonna say, James, you gotta go, don't you? Right? You never thought you'd see a keynote doing this, did you? You got to go, right? Because she knows. The last time she geolocated me in a toilet was 2.5 hours ago. She tags around everywhere I go. She knows my mean time to bladder evacuation is approximately 2.5 hours. She saw me buy the beer coming into the movie theater because all of that is data. She knows what movie I'm watching because she geolocates me, figures out where I am. She takes my altitude. Oh, he's on the 2nd floor. Let's see, what's the floor plan of this address? Bing's got all the floor plans of most major buildings in most major metropolitan areas. Oh, he's in theater number 4. What time did that movie start? What movie is it? What are the P times? It's all data. Tweet that shit right there. I'm just making it easy for you. I'm just tossing these little tweetable nuggets out there for you, if you do include me. It's all data. And all of a sudden, I'm like, okay, Cortana's like, okay, James, you can go now, right? And so you go, you got 3 minutes, James, 3 minutes. And you go, and then you come back, and you sit down, and Cortana's like, hey, I just gave him P times. That's third-party data up in the Azure cloud. He consumed that data. He used that data in the real world. Let's pay these people. And so there you begin to think there's maybe some kind of micropayment economy that's going on. So now instead of the developers getting zero money from a bunch of urinating movie-going Swedes, he gets 4 cents, 6 cents, 13. If it's got a Hobbit in it, might be 25-cent P, you never know. Use the same ads auction algorithms that we have now, except we're auctioning actual value. What developer on the planet is going to say no to that? What developers on the planet is going to say, you know what? We're kind of cool with the App Store. We like being one of 2 million apps. We like that. We like the fact that no one knows we exist. We like the fact that the people who need us can't find it. That's what we like. Or are you going to think they're going to want these micropayments? See, that's what these edge machines, these edge devices are going to do. They're going to be intent gatherers, customer acquisition specialists, and they're going to match it with the data that can satisfy that intent. That's how the world works in the autonomous era. It will draw developers because the developers will get paid. Once the developers are drawn there, they're going to innovate. Once they innovate, the users are going to consume those innovations, and those users are going to attract more developers who are going to innovate and attract more users who are going to attract more developers. And all of a sudden, the autonomous era has that same flywheel that created the mobile era, the web era, and the PC era before it. It's developers. You want to find the future? Do you want to get to the future? Follow someone who can code. We always get there first. We decide what the future is. Sorry, Donald Trump. Politicians don't get to decide. The people who can code get to decide the future. So, when you think about the Internet of Things, think about it in this terms. If this thing could talk, right, what would it say? I discovered home automation, and I put my entire house on the Internet of Things. And it was made it easy because there's this little device that's called a Sense. And it plugs into your electrical panel, and it watches all the electrical use, all the appliances used, right? So it was cool. I plugged this thing into my electrical panel. It took probably a half an hour. Well, I might have blown a few fuses doing this. But I got it working, and all of a sudden it went to work like crazy. Turned on the washing machine, and a Sense is like, hey, your washing machine is on, right? Because it knows the laundry room because it's all labeled. Your washing machine is on. Not only that, it's a Samsung model number, whatever. Because this is how the Internet of Things works. These Senses are in houses all over the world, or at least all over the U.S. All over the U.S. And as soon as one of them discovers that's a Samsung washer, it tells all the other ones. And so it's identifying my appliances one at a time as soon as I turn them on. Oh, your heater is this. Right? It got a few of them wrong. My son's got it got all of his amps. He's a guitar player, but he's got a custom guitar. The Sense thought it was a Fender guitar. And so now I said, no, it's a Marco-based custom. Now it knows Marco-based guitars, right? Because that's how it works. The Internet of Things, they all talk to each other. There are two things it didn't recognize. And the first one was driving me crazy. It's like, it's in the kitchen. I've never seen it before. And I'm thinking, what the hell is it? Right? Days are going by, and I'm checking, and this thing is never turned on. And finally, I'm at work, and I get a notification, hey, that thing I don't know about, it's on right now. And so I call a house, and my son answered, and I said, dude, is anybody else home? And he said, no, it's just me. So I knew it was him, right? So I'm like, what are you doing right now? What are you doing? It's really important. Tell me what you're doing right now. He said, Dad, my girlfriend's not here. I promise. I swear. I'm like, no. I don't care about that. What are you doing right now? And he said, I'm eating breakfast. Dad, you're scaring me. And I said, I don't care if you're scared. I've been chasing this damn thing for weeks. What are you doing? And he said, I'm making toast. It was the toaster. Holy shit, it was a toaster. So I went to the little input van, and I said, hey, Sense, it's a toaster. It's a Nesco brand toaster, and this is the model number. And the Sense is like, no, it's not. And I'm like, no, it is. And they said, well, if that's the brand toaster, something's wrong with it because that brand toaster has a completely different voltage pattern. And sure enough, about 2.5 weeks later, my toaster broke. One of the filaments was wearing. It was using more electricity than it should have, and then the filament snapped. So you can imagine, now that it knows what a broken Nesco toaster is, it'll know that it's breaking, and it could perhaps do something about it. Or maybe the toaster itself is on the Internet of Things, and it'll be told, hey, you're dying. I know, right? And then that brave little toaster, that's how I identify the parents in the room, would have to order its own replacement. And you think, okay, you know, how long does it take you to pick out a toaster? You have to do days worth of research just to buy a toaster, but the toaster is going to order the one that's most useful for you. It's going to figure it out. They're going to be self-aware enough, they're going to gather their own data to know what kind of toaster is right for someone in your area, at your income level, and the toasting habits that it has seen over the last few months of its existence. There was another device that it didn't recognize, and it turned out it was my hot tub. And so I decided I'm going to put my hot tub on the Internet of Things. Because you know what? I'm not married to a liar. I don't have to worry about this shit like some people do. And so I decided I'm going to put my hot tub on the Internet of Things. Now, Swedish people, I'm not boiling my children here. This is Fahrenheit. It's a thing where I come from. And so I decided, okay, I'm going to put this thing on the Internet of Things so my sense will know about it. And so if a hot tub could talk, what would a hot tub say? That's how I want you to think about the Internet of Things. If this, whatever it is, what would it say? And I thought, well, the first thing it would say is my chemicals are wrong. My pH is high. It would say, there's a human in me right now. It would say, or maybe order its own chemicals. And so that was kind of my design. And so I began with the chemical part. And I'll tell you what, I had no idea that sensor technology was so advanced. $39. This thing mounted on the side of my hot tub. It's got sensors dangling in the water, and it checks all the water quality that I need. $39. I didn't even have to do anything. And it's got a port. I can read the data off of it and process it offline myself. And so now I've got the water quality done. And so here's where the machine learning began to kick in. I told it, check it before I get in, check it after I get out. And so it began to realize what dirt, they're called undissolved solids. It sounds kind of gross, right? That I leave behind. And it began to figure out, okay, this is the exact chemicals I need to inject into the water as soon as James gets out in order to erase his presence as quickly as possible. And then my son and my daughter, they both are heavy users of it, and it began to learn about us. And it realized pretty quickly my daughter, this appalls her, is the dirtiest of the three of us. It figured that out all by itself. And my daughter's like, there's no way. She said, Dad, you're the dirtiest. What do you mean I'm the dirtiest? She said, well, you don't always smell very good. And so we looked at the data because our water flow, all my plumbing is on the Internet of Things too. And so she looked at the data and she's like, look, the showers say I shower more than both of you all combined. And she's right. But she uses, makeup and hair product and lotions, and all of that accumulates in the tub, and the hot tub notices that. And so this kind of stuff you almost get for free. The next was opening and closing the lid, and that was easy. The motors are out there. You just bought this thing, and it comes with its own app. And so I had to, decode the data and embed it in my app, and now I can open and close the lid. Because if you inject bromine or chlorine, you got to have the lid open. Otherwise, it accumulates on the lid, and it gets nasty. All right, so now I can open and close the lid from my phone. And then the next thing was a human in. How do you make it human aware? And so I went through all these, okay, maybe you badge in and it knows who you are, and then you sit in. That's stupid. Maybe you do a little laser and you walk through it as you get in, and it gives you a signal. It says, okay, somebody's crossed this boundary. But that didn't make any sense either. So I started doing research, and I found this moisture-sensitive tape It goes from the bottom of the hot tub to the top of the hot tub, and it detects water level. So when you sit in my hot tub, of course, you displace water, and the water level rises. And so that's how it knows there's a human in it. And so it began to see me, right? I was in, Monday and Tuesday, it saw the same water displacement. And so it's like, that's how AI works, right? You tell it an answer, and then it learns the answer, right? Jennifer was telling, this is a lie, this is not a lie, this is a lie, this is not a lie. And so I told her, that's me. I weigh 185 pounds. And so now it knows what a 185-pound person, how they displace water. My daughter weighs 20 pounds. I have no idea. I can't pick her up. My son weighs 140, and so now it's got this. And so now another human can go in, one that has never seen before, and I always let them go in first. I'm like, no, going in, right? And then they sit in, they're like, oh, this is nice, right? And the water's kind of, doing all this, and then finally it gets in. It's like, okay, this is the water displacement, my estimate of the water displacement. That person weighs 215 pounds. And so then I have a conversation. I'm like, dude, you're looking, you're on a diet? You're looking kind of ripped. What are you weighing now? And they're like, I weigh about 210. And I'm thinking, okay, it'll adjust my code a little bit here. And it's gotten really, really accurate. You sit in my hot tub. And so now I'm thinking, can I begin to do more stuff with it? Can I maybe diagnose diseases like of the skin? Eczema is the one I'm working on now. Can I get a water sample and detect issues with the human that's sitting in it? Right? And all kinds of cool stuff have come out. It's like one time I was traveling in Europe, and my hot tub sent me a notification. It's like, dude. I told it to call me dude. Dude. There's 305 pounds of human flesh in me. If it hasn't met you yet, it calls you human flesh. Right? And I'm thinking, who in the hell is in my hot tub? Note to self, install camera. But who in the hell is in my hot tub? 305 pounds. Who do I know? And I'm racking my brain. I couldn't come up with anything. And so then I thought, well, maybe it's two people. Uh-oh. I subtracted my daughter's weight from 305, and I got Dylan. Not a fan of Dylan. If it had been 10, 15 pounds lighter, it would have been Kevin. I'd have been fine with that scenario. Kevin is a nice kid. I like Kevin. I don't like Dylan. And I'm thinking, shit, I'm in Amsterdam. My hot tub's in Seattle. Now what? And I realized I've got a feature, and I did. I'm sorry. I'm a bad parent. Close lid. And like 5 minutes later, I get a text from my daughter. She's like, Daddy, my hot tub is going crazy. And I said, no, sweetheart, you triggered the chastity protection feature of my hot tub. Tell Dylan I said hi. And so all of these scenarios, do yourself a favor and just put something on the Internet of Things. Do yourself a favor and use some of these algorithms that Jennifer was talking about. I don't know what they do. I just call them. And they work. So that's the Internet of Things. And so now you begin to think of these hot tubs would talk like the senses talk. And the hot tub might say, hey, what chemical are you buying? And actually, they're going to figure it out. My hot tub's already figured out the cheapest place to source chemicals from. And it could talk to the other hot tubs and tell them, hey, welcome to Seattle and the Internet of Hot Tubs. For our particular climate, which is rainy and shitty, kind of like yours, this is the best chemical. And, they'll shop sales and begin to figure things out. And now you have to think, well, what about advertising? These chemical manufacturers are sending these glossy-ass brochures to the human hot tub owners with these people with like ripped abs and shit, right? And the hot tub doesn't care about ripped abs. The hot tub knows what the best chemical is. So how are you going to market to a bunch of machines that have the data and they know the best answer? Advertisers are in trouble. You can't advertise to a machine. And so instead, there's going to be some sort of a value marketplace that we're going to have to design. We're going to have to figure this out. How do you get hot tubs to use your chemical? Well, let's think this through, right? The hot tubs are going to tell you, here's the formula that makes that one the cheapest. That's it, right? There's the formula. For the money, that one lasts longer than any other. And so you're going to have to figure this out. Easiest one would be to turn the price lever. Just lower the price to a point where hot tub said, aha, now you're the cheapest. I'm going to use you. And then it'll tell all the other hot tubs, and all of a sudden your chemical is beginning to penetrate the internet of hot tubs. But you're not making any money because you had to lower the price too much. So now you have to understand what other value the machines might pick up. Maybe you've put a skin conditioner in your chemical, and the machines notice that their humans are getting out, and they're not showering. And so they realize, my human likes this chemical. And they begin to buy that one. Advertisers are going to become data scientists. Okay, so let's kind of rethink this. It's data, it's hardware, it's IoT, it's sensors, it's beacons, it's machine learning, it's AI, and there's one more that we have to talk about, invisible user interface. The user interfaces that they're going to go away. They already should go away. My Microsoft band, I have to tell it I'm going running. Right, I have to, okay, here we go. And you have to swipe, swipe, swipe. There it is, run. And now it's acquiring signal, acquiring signal, acquiring signal. Would you like to run anyhow? Yes, I'll start my run. That's a lot of UI. When really, couldn't it just figure out that I'm running? I've been going 2 miles an hour maximum all day. All of a sudden, I'm whipping down the road at 6 miles an hour. I'm running. We have so much UI. We got to stop thinking about UI. UI doesn't make any sense. PowerPoint this morning. I open my laptop, and I'm like, PowerPoint. Right? I'm giving a freaking talk. Of course I need PowerPoint. PowerPoint. Let me introduce you to Outlook. Have you never met? It's right there. I'm giving a talk about the future. That's the deck I always use when I give the talk about the future. But no, I got to say, launch PowerPoint. PowerPoint's like, oh, shit, he picked me. Right? It's like, oh, I'm coming, James. I'm coming, James. Okay, what do you want to do? Open a file? Oh, shit, I would have never guessed, right? What file do you want to open? Here's 100 of them. Which one do you want? Why do we have all this UI? Look at that guy. Look at that shirt. What if that shirt was on the Internet of Things? What would a shirt do on the Internet of Things? It would sell itself, right? The shirt would know that I sell these for charity. And so all you have to do, maybe, I don't know what the gesture I'll design. I don't know what the gesture is going to be. But you make a gesture toward my shirt, and all of a sudden, that shirt is shipped in your size and your favorite color to your house, along with a receipt that says you just donated to charity. No user interface. Not allowed. Design the hardware, design the machines that make it unnecessary. So all of these experiences can be rethought with data. If you think about it, everything you've ever done, every intent you have ever had, somebody else has already done it. And so things like, how much would it cost to take my family to Europe for Christmas? Answer that. You got to go to all these travel websites and, okay, what about how much would it cost to go to Stockholm? How much would it cost to go to Vienna? How much would it cost to go to Belgrade? How much would it cost to go to London? You're going to be researching this shit for hours. But the data's there. The amount of money people have paid for a family of 4 to go from Seattle to Europe is a known quantity. How do we get it? And how do these answers just come up? What's the best flight from Manchester to Singapore? Go on, figure it out. Figure it out. Oh, Manchester to Singapore, and then you get a bunch of text. there's 106 different flights. No, there's not. There might be 106 different ways, but there's only 3 or 4 ways that people actually use. I want to know what those are. I want to know what the satisfaction of each of those are. I want to know the total time, right? It's crazy. It doesn't make any sense the way we do things. I turned 50, and I've began to notice this old body just doesn't work like it used to. I'm not the only guy that's turned 50. You're not the only woman who's experiencing menopause. It took me months to research this because of all the bullshit ads that are on the web. They want me to do things, right? The first one was, oh, you need more testosterone. I started growing horns, man. This shit doesn't work. I don't want horns. I just want to have a little more energy, right? It took me 6 months to figure out that there's basically 4 different things, right? There's hormones, there's enzymes, there's amino acids, and there's supplements. And so I started experimenting with them, and I figured it out, man. I figured out the magic formula. I found the fountain of fucking youth. Go on and try to replicate it. And it's going to take you 6 months. But see, the machines would know. The machines would know. Holy shit, look at James. My God, his body is it's wow. And then as soon as somebody else had the intent to figure their 50-year-old body out, my data would be available to those machines. It's all the data. Where's the best happy hour? With outdoor seating and open tables. The restaurant knows that it's happy hour. The restaurant knows that some of the tables are, right? The sensors that are in the restaurants now, we have a cafe number 9. We put sensors under all the tables at Microsoft. And so we know if there's somebody sitting there or not. You can walk up to the cafe and say, I've only got 20 minutes. I need the shortest line, and I need a table that's free. And it'll tell you what food you can get and where to sit. We have a parking garage. It's on the Internet of Things. Building 31. If you're ever at Microsoft campus, go drive into Building 31 and look at all the sensors. And we're connecting it to the conference rooms so that the parking garage can tell you where to park to get to your conference room the fastest. What's the closest parking spot to my conference room? Let's binge a show today. Netflix knows what I watch on Netflix. HBO knows what I watch on HBO. Hulu knows what I watch on Hulu. Amazon knows what I watch on Amazon. Holy shit, I'm not feeling well. I just want to binge a show today. My TV knows what I'm watching. My TV knows all of those channels. So my TV's like, hey, I saw James watching Game of Thrones. I saw James watching the Vikings. That's a badass. You all are badasses. You all realize that? It's intimidating being up here. If Ragnar Lothbrok is in this room, I'm on your side, dude. It would recommend Marco Polo, which is on a completely different network, because it would notice the people that like those 2 shows also like Marco Polo. It's in the data. All this is in the data. Somebody else has already figured all this shit out. And we're still going through Bing and Google and getting ads. Ads don't fit in the New World Order. Okay, I'm down to a minute. Last thing to talk about. The other technology you need to begin to think through, because over the next 10 years, it's going to become more and more real, is mixed reality. And this started with Pokemon Go. So the way mixed reality works is a different way of thinking about how to program. Instead of writing a program and putting it on a machine and then getting users to install the app, that doesn't work. It doesn't work like that. You write your code, and then you attach it to time and space. Latitude, longitude, altitude, temporal, quadruple. And then if anybody comes within that latitude, longitude, altitude at some certain time, something executes, right, in this Pokemon. I've never poked any Mon. I don't know what they do, but you can interact with them, right? And of course, HoloLens kind of raises the bar for this, because HoloLens can make you see things that aren't really there, and it tricks your brain, right? You understand, like, when I look at you, you understand you're an image inside my head, right? That's the way the brain works. I look at you, light shines off of you, it hits my eye and my brain are like, that's what the dude looks like. That's how far away he is. That's how that deep. That's the movement that he's making. This is an image inside my head. That's what HoloLens does. It shines light on the layers. And if you look at the HoloLens, you see the layers. There's different materials in each of those layers. There's coatings on those layers that allow us to get a really rich three-dimensional image in your head, just like your eye and brain already work. And so you could imagine, things just kind of hovering in the air, watching sporting events. And then, thank you, Jennifer, for doing such a good job of explaining how the brain works, because you're not going to always have to wear glasses for this. We're getting better and better. Elon Musk just invested $4.3 billion of his own money, right, which is like me, spotting you a fiver, to begin to read brainwaves as data. And so the future may be completely not real, which means that the light pattern that I just learned because I looked at you, I no longer need you to be present to make that light pattern do whatever I want it to do. And if that doesn't creep you out a little bit, you really are badasses. So, this is getting a little dark, isn't it, right? Where will all this lead? Here are the things we need to begin to think about, right? What's left for humanity? Once the machines are driving our cars, making our decisions, determining our entertainment, taking care of our garden, taking care of our house, what's left for us? The question here is, what doesn't reduce to data? The field of law completely reduces to data. The field of accounting and finance completely reduced to data. See, in this era, it's not just the blue-collar jobs that go. It's the white-collar jobs, too. I've thought this through. There's very little that doesn't reduce to data. What about the singularity? What about the point at which the machines get so good that they're smarter than us? What happens when the machines wake up and say, holy shit, I'm me. You're my creators. Will they worship us the way we worship our creator? Or will they read Wikipedia and realize what a fucked up species we are? Right? We need to keep the machines away from Wikipedia because they're going to find out about Trump. They're going to find out about the Kardashians. They might be right to kill us. And then this is the real scary part. As we reduce, I promise only a couple more minutes. As we reduce the brain function to data, and that's what we're doing in the Human Brain Project, just like we did it in the Human Genome Project. We reduced the human genome to data in 13 years. And within 20 years of starting that project, we are editing genes. We're removing disease. We're removing characteristics from the gene pool. We are now, with the same veracity but much more powerful machines, mapping human brain function. Once we figure that shit out, and by the way, we already are, things like depression, bipolar, anxiety, schizophrenia, we might be within a decade of wiping out mental illness. A little machine implanted inside our brain, a little spot of dopamine 30 seconds before that panic attack happens, and it doesn't happen. Perfecting our memory, making our processing so powerful that we begin to become superhuman. See, that's the way the machine symbiosis occurs. It solves a bunch of good problems. It solves a bunch of valuable problems. Who wouldn't want a life without depression and panic? But then what? We all can't get this at the same time. Humanity has never adopted technology all at once. The rich get it first. There are going to be a period of time on this planet where we are going to have multiple species of humans. The machines, the human-machine hybrids, and the rest of us. World War III won't be fought among countries. World War III will be fought among species. But it's too powerful. We don't solve terrorism without technology. We don't solve global warming without technology. You take technology away, we can't feed this planet. We can't feed the 9.8 billion people that they're predicting are coming. Technology is not an option. We have to think this through, and we have to think this through now, and it's people like us. It's the IT pros and the developers. It's people who can code. It's people who can wield this shit and not just use it. We can't sit on the sidelines. We got to think this through. We cannot allow the lawyers and the politicians to make these decisions for us. We have always done this as technologists. We have decided what the future is going to be. This choice is still ahead of us. So what are we going to choose? Because it's time. It's time to face this future now. By the way, if you want, follow me on Twitter and all this other shit. Take a picture of that. What doesn't reduce to data? There's two things I can come up with. One is the ability to code. We should all rejoice in that. No machine has ever written its own code. Oh, they generate code, but they generate code based on an algorithm we give them. Artificial intelligence really isn't artificially intelligent. It's algorithmically impressive. It's the data that makes it smart. It's the training of the data. It's the cleaning of the data. It's the data is the reason these algorithms are so smart. No algorithm, no machine has ever said, look at this code that a human gave me. Fuck that code. Oh, you want to take a picture of that? Just make sure we good? God, I love Swedish people. I get in trouble when I do this in the States. I get in a lot of trouble. I mean, human resources and I, we've met. No machine. No machine has ever ignored the instructions that it had and done something on its own. We don't even know how to approach that problem, so rejoice. The second thing is art. It's creativity. The machines may be able to play our games, but they can't create games. And so creativity is actually the subject that I'm going to end on, because for 2.5 hours this afternoon, I'm going to be giving a seminar on creativity. As humans, we have to get much more creative in order to stay ahead of the machines. My name is James Whitaker. I work for Microsoft. Peace.
Thank you. Thank you, James. Amazing and scary at the same time. Och missa inte heller de exklusiva 2,5 timmarna som vi har på eftermiddagen med James Whitaker då han ska prata om kreativitet. Nu börjar det bli dags att stänga ner stora scenen och ge oss ut i alla spännande sessioner. Några grejer innan ni går. Missa inte Lollipop-maskinerna och hjälp oss utvärdera. Ni kommer också få en utvärdering skickad nästa vecka och jag ber er ödmjukt svara på den. Som jag sa igår, ni sätter ribban för nästa år. Så hjälp oss och berätta vad ni tycker. Glöm inte heller att delta i vår tävling. Och om ni älskar TechDays lika mycket som jag gör, så föreslår jag att ni går hem och sätter en blocker redan nu över 24 och 25 oktober nästa år. Så ses vi då! Ha det kul där ute! Tack för i år!